Well, hi, good morning. Thank you so much for joining me in my shop here for, I guess it's day 3 on this radio. Things have been going very well with it. So today is all about aligning the radio, and this radio is called a Minerva. I just learned the manufacturing name. I've never heard of that before. Minerva 119W is what this particular radio, or W119 I think is what it is the model number. So it's made in the USA. I'm guessing it was just exported to Canada and sold here back in the day. Here it is with me now. So what we're going to do, since I now know the model number and that, I have the schematic. We're going to go through the schematic and get ready to do an alignment on the radio. And although it's performing quite well already, pretty sure if I align it I can make a mess of it. Let's check into the schematic here. Okay, so this is a download from Radio Museum. I'm a member of Radio Museum. And this is like a lot of these sheets, someone has taken the time to take various pages and paste them together into one sheet of everything here. So let's have to look at this very carefully to catch all the little details on it. So here, of course, is the radio. The first thing I spotted when I looked at this was, hey, wait a minute, the tubes in my radio aren't 6, they're 12. 12 SK 12, and this is not a 25, it's a 35 L6. What's going on? And down here you can see an alternate set of tubes. Oop, where? Somewhere in here. Somewhere I saw it. Where did I see it? Here. No. So here it is, down here. Alternate list of tubes. So this goes with the W119. The W119A is this radio with the 6-volt tube, so not much difference otherwise. Tubes are just directly in series. There's no dropping resistor at all under this arrangement, which is why they did it, I'm sure. Whereas up here, you have to have a dropping resistors in here. Right there, that one there, I guess. So, okay, so other than that, I think we can look right at the schematic and follow it right through. But let's just keep looking for other bits of information. Pointer settings. Gang closed. Pointer covers A. Covers A. A, C, and B. So they... Oh, look at that. It is the holes I noticed. Well, okay, great. So this is fantastic. We can check the location of the pointer, and we already know it's not right, because when I close it, the pointer was way over here somewhere. It wasn't covering A. Fantastic. Glad I spotted that. All resistors 1/2 watt. K is 1,000. M is 1,000,000. In a lot of radios, M stands for the French word mille, 1,000. So occasionally you'll look at one of these schematics and you'll see an M like that. And this actually means 10,000. So that's why they're clarifying it here, to avoid the confusion. So in this case, M means 1,000,000. K means 1,000. Right there. 470K. Good. Tube complement written again here. Model. 10.5. Is that the date? Here they're noting the alignment items. So here's the 2 IF cans and numbered 1, 2, 3, 4. Here we see 5, 6, and 7. This is probably an antenna adjustment. And this, I'm not sure what that would be actually. Maybe that's resonating against the loop antenna back here. Don't know. Shall we look over the actual schematic? There's some instructions here. Stator front section gang open. Stator front section. It's generator connection. So you connect it to the stator front section using a condenser of 0.1 microfarads. That's the IF frequency. Do that. Excellent. Okay, that's no problem. Very straightforward. Okay, let's look at the actual schematic here. So this is your basic radio. Rectifier generating some high voltage. We got that inductor I spotted helping filter it. That is applied. Here's the positive coming up on this line. So this is the positive line in. So we're feeding all tubes. Well, this one we're feeding probably the highest B plus through here. Here B plus is being knocked down by this resistor a bit. Looks like the B plus goes right through here. Remember the B plus on the on this tube was low compared to the other tubes. It comes right through here. Here it's meeting up the two screens in this tube. Continue on. How did the plate get its supply? Well, the plate supply sneaks up this way through here. All the same voltages. No resistors in here. Oh, speaking of double. What's going on here? So here we have, it's hard to see, but there's the plate coming down. There's the capacitor tying over to the grid of the next tube. 47K, 4700 ohms. You know, this one would appear to me that the plate is actually going to have a lower voltage than the screen on this tube. 6SK7, 2 6SK7s. Now what do we got happening over here? So the tuning capacitor is shown with this curved arrow here. So this is one of the tuning capacitors. The other one is sitting here, hard to see, with its trimmer. This shows the frame of the capacitor tied to ground, but I saw it on rubber grommets. Antenna connection, just so you can follow that again. From the antenna, if you hook one up, the wire just goes, on this diagram, goes around once and then connects to the chassis. It doesn't actually enter into the radio circuitry. The radio circuitry is getting its signal from transformer action here on this. My experience with these, well, I won't say anything here. So this is tuning against this coil. So the antenna, like a lot of these radios, the antenna is an integral part of the radio's ability to receive. It's not just picking up signals, it's a tuned circuit here. And this is the local oscillator here. The local oscillator is driving the grid 1, which is typical. The last radio I did, they had it driving grid 3. They had it the other way around. The cathode current does not go through this coil. This doesn't go. How this works, I don't know. I don't know how this works. Sometimes they use these elements inside the tube as if they're a plate. Is that kind of what's going on here? I don't know. Somehow, anyway, the oscillation set up right in here. Goes through here for, like out of this tube, there's a 455 component that'll sneak through here and carry on if it exists. So this is biased on here. Okay, and I'm pretty sure we'll find out what this line is here when we get a little further through the radio. Amplified here. Screen voltage, there's the big 0.25 that I replaced right on the screen here. Also working against the plate on the far side of these coils from the tube. That's a really important capacitor. Okay, so we roll through here. The output is then shot through both of these rectifier plates. So we get a rectified current flow. It's going to build up a charge on this capacitor here. This big resistor is going to isolate away what's happening over here because it's fairly low impedance from what's over here, because this has to be high impedance, so this is going to work its way to grids. So a little DC building up here, because there's no current flow really through this resistor. The same voltage appears on this side. So you get a negative voltage here because of the way these are arranged. If you arrange these different, you get a positive voltage. It wouldn't do you much good, but with a negative voltage you can play a trick in the radio and trick these first couple of tubes to not amplify as much. So a strong signal coming out of here actually turns down the radio over here. Almost all radios work that way. That's why on a lot of these radios, when you tune between stations, you hear a pile of noise, because the voltage developed here has disappeared, and so these tubes are going wide open. They're amplifying like crazy. And what are they amplifying? All that noise. And when you reach a station, the noise is suppressed because voltage begins to develop here, DC, and then that's applied on these grids. Reduces the gain of probably all these tubes. Maybe not this very first one. Oh yeah, even the very first one. They're all in on it. Okay, so the rectified signal still contains the audio information, and now it's fairly easy to recover it once it's rectified. So you feed that, let's just follow this bottom of this coil. There's the RF snuffer capacitor through this resistor. There's a phono input on this radio. I don't remember seeing a phono input on it. So I see no phono input on here. So that would be for the, that's probably one of the deals with the model change. The model 119A has a phono input. So that's not there. So this comes down right through the volume control, 500K. Bulk of the voltage is falling across here. DC and all. And then, how did they get the AVC here? Right up in here. Ahead of this 47. Off she goes, so we come down here. Now there is some DC flowing this away, so we have a blocking capacitor here. Change the volume, different amounts of signal carrying on. Get over here. Great big resistor, big whopper here, and then up to the grid of the triode. So this tube does two jobs. That has, it's not even aware it's 2 in 1. So we're looking at the second job here, which is the triode preamp for the output tube. Comes up here. What's going on here? I'm going to guess that's the tone control, poorly drawn in here, kind of crammed in. You know, the person who drew this should have redrawn it one more time. They should have redrawn this just one more time, and they would have got a lot better, especially in this area. That's the drafting supervisor coming out in me. Although I was never a drafts person, so I should really keep my mouth shut. I had no drafting skills. So here we have a cathode resistor, 150 ohms, bypass 50 microfarad. So that, I think, is that little blue capacitor that I've avoided changing. 25 volts rated capacitor. I think I measured. Did I measure 6 volts on here or something like that? Did I measure that? Maybe I didn't even measure it yet. So the idea of this capacitor is to make it look to the signal that's going through here as if ground is attached right here. I don't want the signal going through this resistor, just the DC. If that makes any sense. It does make sense. These little wings they've shown here is an attempt to depict this tube as a beam power tube. It's a beam power tube. So they have plates specially constructed inside this tube, and lots of output tubes that I can't really explain exactly the effect, but it has to do with manipulating the distribution of electrons going through the tube to provide a more efficient result, so you get a bigger bang out of this tube. I think that's basically the best I can say. Here we have another little capacitor up here to ground, which I think is another RF snuffer, in case some has made it all the way here, I think. Permanent magnet speaker with transformer. So that transformer is mounted on the speaker. You notice this ground connection here. It's very important to spot that, because we're probably going to want to put a instrument on the speaker output here to monitor its level, and I got to pay attention that one side of it is grounded, or I'll put my ground on the other side. Things won't work out well. So the actual adjustments we got to make here. First we do the IF at 455, 1, 2, 3, 4, maximum output. Then we do antenna post, antenna post. I guess they mean in this radio the wire hanging out. Oh, that's right. There's a post on the back and a wire soldered to it already. So wire soldered to the post. A couple hundred picofarad capacitor there, and we're done. Great. So that's kind of my tour through the schematic here. I think I picked up everything I need to note. Great. Okay, so I'm just getting the equipment connected here to do the work, and the first issue is, where do I connect my output meter? Or more specifically, I saw the ground connection on the speaker voice coil leads, and so I want to make sure my grounded lead goes on the ground here. That's because I'm going to have other... Ooh, what the heck is that? It's like the stuffing is coming out of the speaker. Stuffing? Oh, that might be somebody's repair attempt. I don't know, can you see that? It's a little bit of like cotton batting or something stuck in there with some glue or something. Or is it a spider web? You know what? I think it's a spider web. Very odd. Ooh, I don't know what that is. Oh, you know what? It's part of whoever did the repair here. They did something that involved cotton batting. I don't know what they were doing. Okay, never mind that. Back to the issue at hand, which is which one of these voice coil terminals is grounded. I've looked at them. They both look exactly the same. They both look totally insulated. Well, let's find out. Tricky to tell which is which, because obviously one of these. Let's see, what's the zero on my meter today? Oh, it's a 0.1. .7. Don't fall, meter. Man alive, how's this gonna... 7.6 ohms. .1 is possible. Still not doing me any good here at all. So what we'll do, we'll have the radio playing. I'll apply the ground lead to one of the two terminals, see if the speaker shuts down. And that would tell me. I don't know. Okay. So much for that. Next up is signal generator. Well, I'm all set to go here. Let's just... I'm not all set to go. Okay, let me stop the video for a sec, get things ready. Okay, instructions say use a 0.1 capacitor connected to the stator of the front section. It's going to be here. This will be the input point, and it's between here and the chassis. Just hook it right here, the chassis. This is why it's such an issue to hook up this meter on the speaker, because this ground connection is made on the chassis. So it makes it pretty easy if I put the ground on the wrong side of the speaker to have shorted the speaker right out, not hear any sound, not realize why I'm not hearing any sound, then fiddle around with the radio while the output transformer is shorted. This guy's going to go here. We'll hook him up when we need to. And we're taking, yeah. Okay, so let's get the radio operating. There we go. Get some sound coming out of it, and then we'll get the this meter hooked up. This is a great meter my son picked up at a yard sale for me for a couple of bucks. Replaced one tube in it, and bingo, it's a beauty. When was it? It's a Northern Electric. No date on it. Okay, that should be all ready. Should be all ready. Everything should be ready. Okay, let's see what happens here. Nothing. Nothing. So my guess is this actually, the schematic is really showing you something about the other radio. Now I'm going to clip these on. There's really, wow, it's really tricky to clip it on. There's nothing to clip it to. Just barely on there. Very good. So the next thing is the IF signal generator connecting to the capacitor. And where are you supposed to have this tuned while you're doing this? They say something like a quiet spot. Good luck. Good luck. Good luck. I mean, something that sounds quiet may have a strong signal going through it. That's why it sounds quiet. A strong, unmodulated noise signal. Okay, let's just try it in here. Boom. So my signal generator is running at right at the IF frequency. We should hear it. It's a modulated signal, 1000 hertz. We should hear it. So let's go hunting and see where it is now. I'm going to change the lights here for you. It should make it a little easier to see some numbers. Where are you, Mr. IF? Right on the money. Okay, we're going to turn it up. There we go. Why the terrible distortion? I'm going to tune the radio to another spot here. Yeah, that's better. Okay, now it still sounds just horrendous. should have a nice clean tone coming. Still too much. Okay, the radio's turned way up now. Well, it certainly is indicating the IF is tuned properly, from what, even though it sounds like this. You can still see the meter react. So I'm going to go ahead and try to align it a little better. Okay, double checking frequencies. That's actually 455. And I'm interested in turning down the meter a little bit here. Turn down the radio. And I'm going to turn up the meter. I can barely hear the signal generator in there. Let me turn it up a bit. Yeah, it's just a little better. There we go. Very sharp tuning on the, right on the money. Just off by a hair. This one's off. Turn down a little bit. Really sharp tuning on these. Well, I think that made minimal difference in the operation of the radio, but we have to verify these things. Okay, the next thing is going to be, let's look together. Next thing is 200 picofarad on the antenna. 455. Oh, so this number 5 is a trap. And the objective here is what you're really trying to do is stop 455 from coming out of this radio on its antenna to bother other radios. So they put a trap in it. Now, so the way to test it is to actually try to stick 455 into the radio past the trap. That's what they're saying you try here. Okay, antenna post 200 picofarads. Okay, let me take a minute and get that set up. Okay, so as instructed, I've got a 200 picofarad capacitor here. It's a very small resistor in series with it. Doesn't really matter. And this is the signal generator. Yes, it's still at the same frequency. What do we hear? We could barely hear it when we were jamming it right into the IF circuit, so fat chance hearing it now. So I'm going to crank it up over here. Okay, I'm going to hit it with a blasting signal. Nothing. There's nothing. So not only would this stop 455 from escaping the radio, it's also going to stop 455 from making it into the radio from somebody else's radio. Somebody like me who's got 8 radios running at the same time. Well, just for interest's sake, I'll adjust the trap and we'll see what happens. Maybe, because I'm blasting a very strong 455 on it here. It's a little worrisome. Why no action? Let me tune the radio down. That's a little odd, isn't it? I mean, we're at the IF frequency, and I'm picking this up. So if we double that, we get 900. You know, I'm roughly at 900 on here. That's not very good. My signal generator is very good. It doesn't put out stuff like that. I hear something now. Is that this leaking through? It is. Okay, so I'm at the capacitor closed. Now we can hear it. Yeah, there's a definite null point. That's about it. So I'm now applying quite a strong 455 signal to the antenna. You can't hear it coming out of the speaker at all. That last signal I did the adjustment with was a blaster of a signal the radio will never encounter. Okay, now we're down to the last steps, which is the oscillator and then the front end. Let's take a look at the instructions here. So now we switch to 1400. Oh, wait a minute, you know what we have to do? We have to do this pointer thing before we get too far into it, right here. Gang closed, pointer covers A. Okay, let's check that. Gang is closed. Pointer is way past A. So I think it's just a matter of sliding the pointer on the on here. Now I see the pointer's bent a bit. I'm going to try to straighten it out a little bit. Oh, I bent it the other way. So this is a one-band radio, so if I align it with a bent pointer, it'll be fine on one band. Okay, so now we got to figure out how this is attached to the string. If I get this to come around, I'm not going to be able to see it easily. What I'm looking for, so I can see there's a rubber tube, and the string is in the rubber tube, and then this has been pinched down in the typical way onto the rubber tube. Can we move this? Can we slide this on the string? We probably can. We probably can. So in order to try that, here's the trick. Listen to me now. This is one of the best tricks you'll ever hear from me. We would tend, if we want to slide this on the string, to try to resist the string movement by clamping it back here on this side and then pulling it. And that actually won't work. You actually do the opposite. You try to hold the string. So I'm gonna pinch it up against this piece of metal here. And now you try to slide this way. And it slides easy. It looks crazy. That's how you want to do it. If you hold the string on the other side, as you pull, the grip will tighten on this thing. And you'll have a harder time moving it. You probably still can move it. You run the risk of breaking the string and everything. If you do what I do, easy as can be. There we are. We are now where we should be. Now supposedly, I think it's 1400 is there. Let's just double check this for a sec. So B, whole B, no, 1400. 1400 is up here. 600 is here. Let's go see if that's really true. Tune there. Okay, and then we'll use the signal generator and see if 600 is the deal. Pretty strong signal here. Let me turn it down a bit. No, the deal is, but the problem is the oscillator's off. So it says do the oscillator way up here. Pretty sure that's what it's saying. It's just telling us what this is. It's 1400, 600, and gang closed. That's all it's saying. So I'll go back down to the instructions here. The very vague instructions. 1400, 6, then 7. 1400. So we'll move it up to where 1400 is. So the camera's making it look like the pointer is on an angle. I don't think it is. Shame on you, camera. How does it do that? So at 1400, now we want to get 1400 on here. So it would appear the oscillator is quite a ways off, because that should really be coming in at 14. Okay, the oscillator adjustment is going to be, let's see, do 5, then we do 6. The oscillator's at the back. That's the oscillator. Let's verify it. By interfering with it, you can hear the radio tune as opposed to get weaker and stronger. So what I'm doing is I'm waving my finger around near the stator. And I do the other one. It's very, very subtle. This one is retuning it. This one is just changing its strength. Very subtle. So now we're going to turn this trimmer here and get this thing to pick up 1400. Rearrangement is required. Back one. Okay, 1400 now. Find it? This screw hasn't been turned for a long time. There it is. Go past it a little bit. Put this on 14, jack it up. 14. There's interference right at 14. So this is just doing the same thing as turning the tuning knob, not affecting the... Okay, so I'll say that's 1400. Let's just go down and take a peek at it. So that's supposed to be 600. I think I hear a station there. Maybe not. There's a station at 610 and a station at 590 on either side of this that I can receive here. So unless this is dead on, 600. Pretty strong. 600. So I have this at 600 now. We'll find out where 600 would occur here. That's 600. That's 590 right there. So trusting these dots, I'm going to use the oscillator to push 590 to where it should be, because there's not much up here to receive anyway, so why have it accurate up here? I'll make it accurate down here. So I want to try to pick up that 590 signal again. No luck there. Okay, I kind of messed everything up now. Okay, we'll go back to the 600 spot. It's just the oscillator anyway, so 600 now will go down slowly. 600. So the heterodyne is my signal generator heterodyning with the radio station. I'll try to bring it in at where I think 590 should be. our meter come off? No, that's just it. Some terrible distortion in this. Maybe it's the speaker. Speaker's a little bit damaged. Okay, I'm gonna watch this. Make 590 come in there. Why don't I do this? Make 600 come in here. Do it proper. Not much of a peak visible on the meter there. Okay, there we are. Now we find 590 right there. 610? 610 is from St. Catharines. That's pretty far away from here. No. 640? Be somewhere up in here. I'm pretty sure I've got just bad antenna angles here. That didn't help. Lousy. Okay, we've got one more adjustment to do though. Don't worry about this. This one may peak its performance up. It's done again up at 1400. So I'm going to leave it. I'm not going to adjust the oscillator up here. Yeah, that's a cleaner sounding thing. Okay, next trimmer, other part of the tuning capacitor. Watching the meter. There we go. Oh, not making any difference at all. Oh my gosh, really? Why is that? Let's crank it way down. Well, it's definitely reducing it there. I find a lot of these trimmers, they like to be just wide open. That's what's happening here. But any more open, the screw's going to fall out. I don't like that, but I don't know what to do about it. So let's just go down here now and give it a little listen. Let's give it a listen. Let me get this off here. I think it might be. Ah, leave it. Not very good. Let's try the sports channel here. Okay, that looks like the best antenna orientation. I'm going to take this clip off here. Ow. Jeez. There's hardly anything holding the clip on, but you can't yank it off. Visit your local dealer for details. So if we take this radio to another location out of my shop, the quality of the sound will be very good, I'm sure. It's really tough here. And now there's a French station up here. Let's see if we can find that. What is doing that in here? I don't know. Something is bumping out a terrible noise here. I've got my phone in my pocket. That's bad. So this is some new interference signal. I don't normally hear this. And it's just sitting right on top of that French station. This is what I need. More new noise sources. Now we'll just see if we can just pick up anything between here and here. There's a signal at 840. Or is it 820? Maybe it's 820. Funny 820. Very tricky to catch. I don't know what that is, but it's not funny 820. The fact that we picked something up is pretty good. That's going to be not bad. Okay, she's done. She's finny. I just have to repair the speaker a little bit, and this guy will go back to its owner from here. Fantastic. So thanks a lot for watching the series. This was one of the easiest radios I've ever done. Thank God, because the last few have been really difficult. Today I'm taking delivery on 3 more radios that need to visit my shop. So I'll be busy. So thanks a lot for watching this. And, see you on the next video.